Welcome back. In this video, we're going to go over an exercise where we will find extrema on a closed interval. Here the given function is x squared minus 8 ln x, and the closed interval is 1 and 5. And here is the guideline to find extrema on a closed interval. So first we're going to find the critical numbers of f in the open interval 1 and 5 for our problem, and evaluate the function at the critical number or numbers if they exist. And then we're going to find f evaluated at the endpoints, and by checking those values we're going to find the least or the greatest ones, and then the least one is going to be the minimum and the greatest one is going to be the maximum. All right, so why don't we go ahead and hit the road. To find critical points for f, we need f prime. Well, we have two pieces here. One is x squared, so we take the derivative of that first, and then we take the derivative of 8 ln x. Well, the derivative of x squared is just 2x by using the power rule. And the derivative of 8 ln x is minus 8 times the derivative of ln x. And if you use the formula card for differentiation, you can look at the derivative of ln x from there. It's just the derivative of x divided by x. So the derivative of x divided by x, but that is what? 1 over x. So let me just rewrite this. 2x minus 8 over x. And critical numbers of f are the numbers that make f prime 0 or undefined. So let's try to find x's for which f prime is exactly equal to 0. And solve this equation for x. So why don't we add 8 over x to both sides of the equation so that this looks like 2x equals 8 over x. And eventually we can do the cross products, right? To achieve that, why don't we put a 1 here and look at these cross products. So on the left you have 2x times x, which is 2x squared. On the right you have 1 times 8, that's equal to 8. Dividing both sides by 2 and taking the square root of both sides, x turns out to be plus or minus root 4, which is 2. Two critical numbers coming out of f prime set to 0. These are plus or minus 2. And in the next step, we're going to find x's for which the function f prime is not defined. Well, as you see, f prime has two pieces here. One is 2x, which is defined everywhere, but 8 over x is not defined at x equals 0. So in other words, x equals 0 makes f prime not defined. We have then critical numbers. Minus 2 and 2 come out of setting f prime 0, and 0 is the one that makes the function f prime undefined. So you have 3 critical numbers. In the next step, we're going to evaluate f at the critical points as well as the endpoints 1 and 5. In this step, we're going to evaluate f at the given points, but you're going to make sure that these points are in the domain of the function. Okay? So here we have negative 2. As you see, ln of a negative number is not defined, so this is not the case anymore because minus 2 is not even in the domain of that. In fact, minus 2 is not even in this interval. Okay? And as well, 0 makes this function undefined, so 0 is not in the domain, and 0 is not even in the closed interval that I'm trying to find extrema on. So we discard these two function values immediately. And if you use your calculator for x equals 2, x equals 1, and x equals 5 for the function evaluation of f, so the least of those is like negative 1.54518. And the greatest of those would be the maximum, so that's 12.1245. And here is a graphical outlook for the function x squared minus 8 ln x. So we use this graphical outlook to verify that we got the right relative extrema. As you see, the maximum happens at the endpoint 5, and the value is 12.1245. And the minimum happens at one of the critical points where f prime was 0. That means at this point we have a flat tangent line, right? F prime at 2 equals 0. We have a flat tangent line, and that's where the minimum of the function occurs. And the left end is not a minimum or max. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.